Hello, my name is Zishan. You're welcome to Zishan classes. Today we are going to look into another question from Kinematics. The problem is that there's a block resting on a wedge and it starts sliding down. We have to find the acceleration of the wedge in this problem. The angle of the wedge is alpha. So for you to be able to find the acceleration of the wedge, first we'll name it A1. There are a few things that you need to understand. The first thing is obvious that the block 2 is going to move downwards, and since it's moving downwards, it is going to push the block 1 to the right. There is no friction. There is no friction. We are going to draw the free body diagram of the block 2. We have mg sine alpha, we have mg cos alpha, we have the reaction. Keep in mind that the block 2 moves this way with an acceleration a2. Also, since it's moving with the block 1 and the block 1 is moving to the right, the block 2 is going to have an acceleration this way as well, the same as the first one, a1. So it has two accelerations. First, we'll spot the angles in all the vectors we are showing here. This is alpha, and rest of the angles we have already taken care of. This acceleration here can be broken into two accelerations, one equal to a1 cos alpha and the other one a2 sine of alpha. Now we'll write the equations for the block 2. In the direction along the plane, this way, we have mg sine alpha, the force, the only force in this direction, equal to m times the acceleration in this direction, that is component of a1 acting in the opposite direction. So the resultant acceleration in this direction is going to be a2 minus a1 cos of alpha. We'll keep this aside with us. mg m2g sine alpha is equal to m2 times a2 minus a1 cos alpha. We'll name this 1. Now we'll talk about the direction perpendicular to the surface, to the inclined plane. I mean this way. the forces acting in this direction are m2g cos alpha minus r2. The forces acting in this direction is equal to m2 times the acceleration in this direction, which is only supposed to be a1. We'll also keep this aside. m2g cos alpha minus r2 is equal to m2 a1 sine alpha. We'll name this 2. Now we'll talk about the wedge, the forces acting on it, and the equations for it. We have R1 reaction acting upwards, M1G acting downwards. The reaction which the block 1 applied on 2 is going to act in the opposite direction at 1, the name of which was R2. Now if this is alpha, this is going to be alpha. A lot of students have a lot of problems when it comes to identifying the angles in the problems. I'm going to make a separate video for that. Also, I'll make separate videos for the trigonometric relationships and the resolution of forces, especially mg being converted into mg cos alpha and mg sin alpha. This block is moving to the right with an acceleration a1. So we will write the equations for it. The equations for it are going to look like, first let us break R2 into two components. This one is going to be R2 sin alpha and this one R2 cos alpha. So the only force responsible for the motion of the block 1, the wedge, in this direction is R2 sin alpha, and the R2 sin alpha is going to be equal to m1 a1. We will use the second equation and the third equation to find out the value of a1, the one that we required. So simple. It's going to be, from here I'll take R2 is equal to m1 a1 by sin alpha. This implies that R2 is equal to m1 a1 divided by sine of alpha, and we'll put this value of R2 in this equation. We will eliminate R2 this way. So putting R2 is equal to m1 a1 divided by sine alpha in equation 2, we get m2g cos alpha minus m1 a1 divided by sine alpha is equal to m2 a1 sine alpha, which gives us m2g cos alpha sin alpha minus m1 a1 is equal to m2 a1 sine square alpha. This gives us m2g cos alpha sin alpha is equal to m2 a1 sine square alpha plus m1 a1. This gives us A1 is equal to m2g sine alpha cos alpha divided by m2 sine square alpha plus m1. That's it. The acceleration that we required, acceleration of the wedge, A1 equal to m2g sine alpha cos alpha divided by m2 sine square alpha plus m1. That's it. So, if you have any doubt, you can tell me in the comments. Please subscribe to the channel. I'll see you in the next video. Thank you.